Neutral conductor sizing in the current National Electrical Code generally requires the neutral conductor to be the same size as the phase conductors. However, there are exceptions to this rule. Exception 1, known as the 200% rule, is outlined in NEC section 215.2 at will. If the neutral conductor carries the unbalanced current from multiple nonlinear loads such as electronic devices or LED lighting, it may be sized at 200% of the current carried by any one phase conductor. Exception 2 applies to the neutral conductor leg, as described in NEC section 220.61b. In three-phase, four-wire systems, the neutral conductor leg, which is the conductor that connects the neutral busbar to the grounded neutral point of the transformer, may be sized at 1/2 the size of the phase conductors. Historically, in older versions of the NEC prior to the 1993 NEC, the neutral conductor could indeed be sized at 1/2 the size of the phase conductors for all applications. This rule was revised in the 1993 NEC to generally require the neutral conductor to be the same size as the phase conductors. Therefore, unless one of the two exceptions applies, the neutral conductor must be the same size as the phase conductors. Let's delve deeper into the specific requirements and considerations for each of these scenarios. Understanding these nuances is crucial for ensuring safe and compliant electrical installations. Consider a scenario where you have a significant amount of electronic equipment connected to a circuit. These devices, known for their nonlinear current draw, can cause a substantial amount of harmonic current to flow in the neutral conductor. The 200% rule, as detailed in NEC section 215.2 at will, allows for a larger neutral conductor to accommodate this increased current load, preventing overheating and potential hazards. Now let's examine the three-phase, four-wire system where the neutral conductor leg exception comes into play. In these systems, the neutral conductor leg connects the neutral busbar to the grounded neutral point of the transformer. NEC section 220.61b permits sizing this conductor at 1/2 the size of the phase conductors under specific conditions. This exception recognizes that the neutral current in a balanced three-phase system is theoretically zero, and even in unbalanced conditions, the neutral current is typically less than the phase currents. Understanding the historical context of neutral conductor sizing is also essential. Prior to the 1993 NEC, the allowance for sizing the neutral conductor at 1/2 the size of the phase conductors was a common practice across various applications. However, with the increasing prevalence of nonlinear loads and the potential for harmonic currents, the NEC recognized the need for a more stringent approach. The 1993 revision marked a significant shift, requiring the neutral conductor to generally match the size of the phase conductors, unless specific exceptions apply. When determining the appropriate size of a neutral conductor, it's crucial to consider several factors, including the type of loads connected to the circuit, the presence of nonlinear loads, and the specific requirements outlined in the NEC. Consulting with a qualified electrical engineer or electrician is always recommended to ensure compliance with the latest codes and standards. Failure to properly size the neutral conductor can lead to various issues, such as overheating, voltage drop, and even electrical fires. By adhering to the NEC guidelines and understanding the underlying principles of neutral conductor sizing, you can contribute to creating safer and more reliable electrical systems. Moreover, it's important to stay updated with the latest revisions and interpretations of the NEC, as electrical codes are constantly evolving to address emerging technologies and safety concerns. Now, let's further elaborate on the 200% rule, as it applies to circuits with multiple nonlinear loads. Nonlinear loads, such as electronic devices and LED lighting, draw current in a non-sinusoidal manner, resulting in harmonic currents. These harmonic currents can accumulate in the neutral conductor, leading to a significantly higher current flow compared to the phase conductors. To mitigate this issue, NEC section 215.2 at will allows for sizing the neutral conductor at 200% of the current carried by any one phase conductor. This provision ensures that the neutral conductor can safely handle the increased current load without overheating or experiencing excessive voltage drop. It's important to note that the 200% rule is not a blanket allowance and should only be applied when the neutral conductor is expected to carry a significant amount of harmonic current. A thorough analysis of the connected loads and their harmonic characteristics is necessary to determine the appropriate neutral conductor size. Furthermore, consider the neutral conductor leg exception in 3-phase, 4-wire systems. NEC section 220.61b permits sizing the neutral conductor leg at 1/2 the size of the phase conductors under specific conditions. This exception recognizes that in a balanced 3-phase system, the neutral current is theoretically zero, and even in unbalanced conditions, the neutral current is typically less than the phase currents. However, it's crucial to ensure that the system is indeed balanced and that the neutral current does not exceed the ampacity of the reduced-size neutral conductor. Proper grounding and bonding practices are also essential to minimize voltage imbalances and ensure the safe operation of the electrical system. In addition to the NEC guidelines, it's important to consider industry best practices and manufacturer recommendations when sizing neutral conductors. Consulting with experienced electrical professionals can provide valuable insights and help ensure that the electrical system meets all applicable safety and performance requirements. Remember that electrical codes and standards are constantly evolving, and it's crucial to stay updated with the latest revisions and interpretations. Regular training and continuing education are essential for electrical professionals to maintain their knowledge and skills. By adhering to the NEC guidelines, understanding the underlying principles of neutral conductor sizing, and staying informed about industry best practices, you can contribute to creating safer, more reliable, and more efficient electrical systems. Furthermore, consider the impact of voltage drop on conductor sizing. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the impedance of the conductor. Excessive voltage drop can lead to reduced performance of electrical equipment and even damage. To minimize voltage drop, it may be necessary to increase the size of the conductors, including the neutral conductor. The NEC provides guidelines for calculating voltage drop and recommends limiting it to a certain percentage of the source voltage. When sizing neutral conductors, it's important to consider the potential for voltage drop and ensure that the conductor size is adequate to maintain acceptable voltage levels at the load. In addition to voltage drop, consider the impact of ambient temperature on conductor ampacity. The ampacity of a conductor, which is the maximum current it can carry safely, decreases as the ambient temperature increases. The NEC provides ampacity correction factors for different ambient temperatures. When sizing neutral conductors, it's important to consider the ambient temperature and apply the appropriate correction factors to ensure that the conductor ampacity is sufficient for the expected current load. Also, consider the type of insulation used on the conductors. Different types of insulation have different temperature ratings. The temperature rating of the insulation determines the maximum temperature that the conductor can withstand without degrading. The NEC provides ampacity tables for different types of insulation. When sizing neutral conductors, it's important to select a conductor with an insulation temperature rating that is appropriate for the expected operating temperature. Furthermore, consider the method of installation. The method of installation, such as whether the conductors are installed in conduit, cable tray, or free air, affects the heat dissipation of the conductors. The NEC provides ampacity adjustment factors for different methods of installation. When sizing neutral conductors, it's important to consider the method of installation and apply the appropriate adjustment factors to ensure that the conductor ampacity is sufficient for the expected current load. Also, consider the presence of other conductors in the same raceway or cable. When multiple conductors are installed in the same raceway or cable, the heat generated by each conductor can increase the temperature of the other conductors. The NEC provides ampacity directing factors for multiple conductors in the same raceway or cable. When sizing neutral conductors, it's important to consider the presence of other conductors and apply the appropriate directing factors to ensure that the conductor ampacity is sufficient for the expected current load. Moreover, consider the potential for future expansion. When designing an electrical system, it's important to consider the potential for future expansion and ensure that the conductor sizes are adequate to accommodate any additional loads that may be added in the future. It's often more cost-effective to install larger conductors initially than to have to replace them later when additional capacity is needed. Therefore, when sizing neutral conductors, it's important to consider the potential for future expansion and select conductors that are large enough to accommodate any anticipated future loads. Remember that electrical codes and standards are constantly evolving, and it's crucial to stay updated with the latest revisions and interpretations. Regular training and continuing education are essential for electrical professionals to maintain their knowledge and skills. By adhering to the NEC guidelines, understanding the underlying principles of neutral conductor sizing, considering all relevant factors, and staying informed about industry best practices, you can contribute to creating safer, more reliable, and more efficient electrical systems. Let's delve deeper into the practical application of the 200% rule and the neutral conductor leg exception, providing real-world examples to illustrate their significance. Imagine a commercial building with a large office space filled with computers, printers, and other electronic devices. These devices, being nonlinear loads, generate significant harmonic currents that accumulate in the neutral conductor. Without the 200% rule, the neutral conductor would likely be undersized, leading to overheating, voltage drop, and potential safety hazards. By applying NEC section 215.2 at W and sizing the neutral conductor at 200% of the current carried by any one-phase conductor, the electrical system can safely accommodate the harmonic currents and maintain reliable operation. Now consider a manufacturing facility with heavy machinery powered by a three-phase, four-wire system. The neutral conductor leg, which connects the neutral busbar to the grounded neutral point of the transformer, plays a crucial role in maintaining the system's stability. By applying NEC section 220.61b and sizing the neutral conductor leg at 1/2 the size of the phase conductors, the facility can optimize its electrical infrastructure without compromising safety or performance. It's important to emphasize that these exceptions should only be applied when the specific conditions outlined in the NEC are met. A thorough analysis of the electrical system, including load calculations and harmonic measurements, is necessary to ensure that the neutral conductor is properly sized. Furthermore, it's crucial to maintain accurate records of all electrical modifications and upgrades, including conductor sizes and ampacities. This documentation is essential for future maintenance and troubleshooting. In addition to the NEC guidelines and industry best practices, it's important to consider the specific requirements of the local electrical authority. Local codes and regulations may vary from the national standards, and it's the responsibility of the electrical professional to comply with all applicable requirements. Moreover, remember that electrical safety is paramount. Always to energize electrical circuits before performing any work, and follow proper lockout-tagout procedures to prevent accidental energization. Use appropriate personal protective equipment such as gloves, safety glasses, and arc flash suits to protect yourself from electrical hazards. By prioritizing safety and adhering to established electrical practices, you can minimize the risk of accidents and injuries. In conclusion, neutral conductor sizing is a critical aspect of electrical system design and installation. By understanding the NEC guidelines, applying the appropriate exceptions, and considering all relevant factors, you can ensure that the neutral conductor is properly sized to safely and reliably carry the expected current load. Stay updated with the latest revisions of the NEC, consult with experienced electrical professionals, and prioritize safety in all electrical work. Furthermore, consider the use of energy-efficient lighting and equipment. Energy-efficient lighting and equipment consume less power and generate less heat, which can reduce the load on the electrical system and improve its overall efficiency. When sizing neutral conductors, it's important to consider the potential for using energy-efficient lighting and equipment and select conductors that are appropriate for the reduced load. Also, consider the use of power factor correction. Power factor correction is the process of improving the power factor of an electrical system. A low power factor can lead to increased current flow, voltage drop, and energy losses. By improving the power factor, you can reduce the current flow, voltage drop, and energy losses, which can improve the overall efficiency of the electrical system. When sizing neutral conductors, it's important to consider the potential for using power factor correction and select conductors that are appropriate for the reduced current flow. Moreover, consider the use of demand-side management techniques. Demand-side management is the process of managing the electrical load to reduce peak demand. By reducing peak demand, you can reduce the strain on the electrical system and improve its overall reliability. When sizing neutral conductors, it's important to consider the potential for using demand-side management techniques and select conductors that are appropriate for the reduced peak demand. Remember that electrical codes and standards are constantly evolving, and it's crucial to stay updated with the latest revisions and interpretations. Regular training and continuing education are essential for electrical professionals to maintain their knowledge and skills. By adhering to the NEC guidelines, understanding the underlying principles of neutral conductor sizing, considering all relevant factors, staying informed about industry best practices, and implementing energy efficiency measures, you can contribute to creating safer, more reliable, more efficient, and more sustainable electrical systems. The key takeaway is to always refer to the most current version of the National Electrical Code and consult with qualified professionals when making decisions about electrical installations. The NEC is updated regularly to reflect changes in technology and safety standards, and it is essential to stay informed to ensure compliance and prevent potential hazards. Electrical work can be dangerous and should only be performed by qualified individuals. Always prioritize safety and follow all applicable codes and regulations.